This is our states of matter review. So during this, you'll want to listen for 3 keywords and email me or message me in Canvas. So my email is, I will type it right here, nicole.richards@besd.net, and tell me the 3 keywords and I will add 100 points to your class craft account. So here we go. So you have solids. We can see these are, if we're describing them, they are packed together. They are very dense. They're the coldest ones. That's right? They're huddling up and they want to be together. They're fixed in this spot. They're going to have a hard time moving, but they are still moving. They're just shaking and vibrating. So it's just such a small movement, we can't actually feel that. But the kinetic theory of matter says that all matter moves, no matter what type of state of matter it's in. All molecules move. So these liquids, they touch and they flow and they slide past each other. So they're easy to get through, but they are touching and rubbing and sliding past each other. So they just kind of take the shape of their container. They're a medium temperature compared to these, and they have a medium kinetic energy. So they're moving a little bit more than these, less than the gas. And then we have our gases, and these are trying to spread out. And as they're spreading out, they're pushing and they're moving up. So they're really trying to go up. So as each of these levels progress, so these gases spread out and become less dense. That's why they can go up. So they're the hottest. So when we're finding the hottest part, we can expect it to be up high. So things like hot air balloons, right? You're pushing that hot air and those molecules are pushing up and they're spreading out and they're becoming less dense, and that's what's making it go up. So solid, liquid, gas. So just the molecules are spreading out as they get hotter and they come back together when they get colder. So here we can see energy is being added, heat is being added to go from a solid to a liquid. We call that melting. So if you have an ice cube and you add heat to it, it now melts and becomes a liquid. Now you take that liquid and you put it on the stove. When you add even more heat to it, it goes through evaporation. So evaporation goes from a liquid to a gas. It's spreading them out. So when we're seeing things like steam or vapor, right? If we watch it, it's going up. The hottest molecules are moving up and pushing out. They're trying to get away from everything else by going up. So then we go backwards and we take away the energy. So that means it's getting colder. The hot gives to the cold. Heat always goes from hot to cold. Hot to cold. Hopefully you listen to that song. I won't sing it for you, but you can go in Canvas and find it on our heat transfer ed puzzle. So we go from a gas. They're all spread out and they're hot and they hit something cold. They want to come back together. They're giving their energy away to that cold thing. And that is called condensation. So when they condense back together into a liquid, gas to liquid is condensation. So now we take that liquid, that water, and we make it even colder. We take away even more heat. That is called freezing, right? We take that water, that liquid, we put it in the freezer, we remove even more heat, and there we have an ice cube. So every time, is the heat being added or is heat being taken away? These are generally more dense, they're more packed together. And then we have our liquids that flow And then we have our gas that is spread out, and they're the least dense usually. So as we stack things on top of each other, you can expect the gases usually to be on top, then the liquids, then the solids. There are some rule breakers. If they're filled with more air, they have more space in them, then they might be less dense even if they are a solid. If those molecules happen to have lots of air and space in between them, then we saw how some of those solid things can float on top of liquids. So we need to think about, how are these molecules acting? What is their speed? What is their temperature? Then as we change, is heat added or is heat taken away? So remember, our solids are usually going to condense and sink, and our things that are having energy added are spreading out and going up. So we can find the hottest part up high, the lowest part down here. So my house actually has 3 levels. So we have our basement, and then we have our main level, and then we have this loft upstairs, and I have super, super duper high ceiling. So it actually looks like that. It like goes all the way up to the top. So in the basement, right, here's the ground, and those cold molecules sink down. So if I'm here, it's like we keep our house at 68 degrees. But when I go down, those molecules that are colder have sunk down into the basement, and it will usually be about 65 degrees, not percent, got math on my mind, 65 degrees down in the basement, because those cold molecules are condensing and they're denser and they sink down. And then if we go up into this loft area, those hot molecules, right, they're pushing up and they're trying to get out up the top. They're going up. And if we go up here, especially in the summertime, like sometimes it will be 95 degrees up here. But if I go like on a normal day, it will often be about like 75 degrees up here, because those hot molecules are rising. And if I go down in the basement, it feels a lot cooler. So in the winter, I like to spend my time up here because it's nice and warm. And in the summer, I like to spend my time down here because it's nice and cool. So as you're answering these science questions, just stop and think, what are these molecules doing? What phase is it in? Now, as it's changing, was heat added or taken away? What are those molecules going to do? And I just remembered I did not give you any secret words. So your secret words that you are going to email to me, and you're not going to tell your friends, because then it's like they got free points and you did the work and they got the reward. Like, that's not how that works. So keep it a secret. So your magic secret words are from our heat transfer song, right? Heat transfer. Oh, I told you I wasn't going to sing, and here I am. Is really neat. It always goes from, there's 3 words. It always goes from. So if you don't know those, you need to go back and watch that heat transfer ed puzzle. So heat transfer, so I'll type it out. Here we go. Heat transfer is really neat. It always goes from blank, blank, blank. Always goes from, what are those 3 words in that song you listen to? Email those to me and I will give you your points.